Let me continue with where I had left off earlier, and then also go back to place where I mean you can have, if you can look at the monitor, you will notice here that this is an outdoor installation where the solar panels have been placed here. At least in the common understanding, we expect that there is a huge amount of energy, sunshine which is available. Is there some way of harnessing it? So, typically one of the easiest ways is to have a simple standalone device, that is you have a solar what you call array, solar panels, and then you connect it directly to a load, and then in case you want to have storage, you can have the storage in the form of a battery in the local place. But what you perhaps have never asked for is, first of all, where do you store the energy, and then what do you do with the energy, and then how do you integrate it well with existing infrastructure. So, this one is from the Karnataka government. I would like to thank my colleagues, which I mean you can see the picture later on. Out of some compulsion, you will notice that it makes sense if you put it far away. And why? I will get back to it in a little course. You see here, this comes from a place called Shivanasamudram, also called the Bluff Falls. So, it is a small thing, 5 megawatt solar power project. I will call it a more like a pilot project. The idea is here is, we already have a what do you call waterfall or based hydroelectric power project there. It is logical to have these huge panels outside very near that place, because when sunshine is available and hence the solar power is available, it is easy to feed it to the grid, and during the daytime it directly feeds the grid. 5 megawatt is a very small thing, probably maybe typically if you take 5 kilowatt per a household peak. So, 1000 what you call households can be run on this, which is of course I mean just ignore it at the minute, I will come back to that. The thing being, we have already a huge feeder network everywhere. Okay, we have a grid network, power is directly fed to the grid, and as long as power is available from any source, conventional, non-conventional. In non-conventional you have wind and typically solar. In the conventional we have hydroelectric and gas or other what do you call non-renewable type of sources. The issue being, it is not as if the load is completely unpredictable. Maybe the clouds you see there, they are not very predictable, but however load is not unpredictable. We know very well in the evening there is a peaking of load. Since we live in the tropics, we have no issue about heating, but elsewhere also the same thing can be done, and it is probably heating is taken in some other level. So, if you go here, you see here it directly feeds to the grid, and storage is the water that is already stored. So, during the evenings when you need power, but solar is not available, but a little bit of wind can be there, hydroelectric as well as the non-renewable or fossil fuel based things can work. This is the practical way of handling these things here. So, I mean I will leave it here. This is something, probably it has something to do with the earth leakage system. These are all the usual transformers. what interests me is the panels which control all this power. You have seen that compared to that small tiny what you call PV modules or one which you are likely to see in your lab, power control is a little similar, and you have a huge audio visual annunciator system which is built into that. So, I will just skip all this fast because it will not make too much sense to you. When I come back, you will be able to. I would like to acknowledge that the whole thing has been taken from the installation which has been carried out by Bharat Heavy Electricals Limited. And you see here, this is the solar cells, these are all the devices which carry the current, and most important is when we current it something to the grid, we need to condition the things. One is, one basic thing, simple thing is the voltage, but then voltage does not tell us the full story. So, you need to track the grid 100% and very close tracking is there, and this is the amount of protection and backup that is required. While that part of it is true, you have a look at something here. Can you see something? I will see if I can enlarge it. So, it is obvious, is it not? In the cooling, in the small thing I have showed you is about just like that, no? I mean, use the simple air conditioner, or you can even have a panel mounted air conditioner which will take care of it. But when the power keeps increasing, you have no choice but to get into proper ducted air conditioning. And you see here we have a small exhaust fan which takes in, and these are probably proper metal clad fans which can take, I think, they are all rated for maybe 200 degrees centigrade. There is no issue, even in the case of fire or in case of any runaway, there is no problem, but typically inside temperatures do not exceed maybe around 70 degrees. So, this is about cooling full racks. Now this will come to the interesting part. This is the back of the installation. Do you see something here which is very, very apt? Keep having a closer look at it. Maybe in this corner I be able to see, oh, I could not capture it here because the actual ducting and all is here on the right side top corner, and you see these beautiful devices what we have here. It is a peculiar long wide fan, a little like what you are likely to find in your air conditioners. It is not an axial fan, it is not a simple radial fan also, it is a longish thing which is most of your rooms and all, when you enter you would have seen this, what is called the air curtain. So, it is something a little similar to the air curtain fan, but what it does is here it takes all the ambient air from outside and it passes it through these ducts. Now, here is where those special type of heat sinks and all which I have shown you make sense. I will just show you one of these. Sir, can you please switch on the other camera? You see here, things like this, rear face of it is where all the electronics sit. The other face, what you see here is where there is a chute and there is ducting. Now, if you see, go back to my monitor, if you see in the monitor, you will see that probably inside here now is where these exhaust, I am sorry, these what you call blowers are attached here, and the thing is exhausted there. Now, you see at the back and the left side, you see what it is here. Here you will notice that there is a louvered air filter. This air filter assembly is required because when you are trying to exhaust things from here, where does the where does this get all the air? So, somewhere in these wherever there is a little gap now, they have installed those filters. So, filtered air enters this, and as if that is not sufficient, this much of various types of power electronics are required, and this orange colored thing is there, no, probably that is where the I do not know, this is some part of the wiring, all the power devices sit here. So, these are all the control switching on and off devices, and at the back we have these coolers. Now, you see cooling is important, whatever you say, under part load if inefficiency can be of the order of 15%. So, that much of heat goes off as inefficient. Little closer look, now can you see here on the top we have those various types of things, which duct the air, and then underneath here is probably where all the cabling sits here. So, cooling is real, and you see the amount of from each of these lot of ducting takes place. All this air is collected and it is taken here, and the whole thing has to be exhausted. So, somewhere in the corner you find all sorts of devices to make sure that the air is ducted. It follows a proper pattern. This is the reality of heating, and at the same time everything should be manageable. So, I think what all I wanted to show you has been covered in this. That is me, that is my colleagues at this Indian Institute of Science, and this is the huge panel which is there. Now, one more thing also here, not related to this, do you track the sun? No. And then tracking is not like active tracking, it is very much possible. Probably they have considered all the things, they have done all the studies and found out a fixed orientation, and depending on seasonality you are able to make it. There are other sundry these things here. Okay, I will go to this main thing. You have seen this something. Oh, it does need its own small batteries to keep the system running. The monitoring system, the switching system needs once again a huge amount of backup. These are all special batteries, collection of cells and all that to make sure they work. I think this is enough. Incidentally, I just wanted to show you a few of the other things. You see here, this one is directly under the panel. While top of the panel is protected and there is a glass and all that, under the panel the sort of protection with reverse polarity, they have diodes inside. Similarly, they have static discharge devices and so on. All of these things are involved in it. So, I just wanted to, since I have the picture, I thought I will show you. You have seen here some, I think only the trained people will know what it is. Obviously, all I can say is a connector and then I should stop. Beyond that, no. This is the inside the equipment. Whether you like it or not, we end up with all sorts of these terminations. Something red and something black, and there are all, you have seen that, no, several screws here, and then do you see something? It does look like a diode, and there is a heat sink here, and the heat sink miraculously is not black, neither is it gold color. I am sorry, neither is it silver color. It seems to be given some other layer. It is not, actually it is not gold, it is some other anodic modified anodic layer. And if you see here very carefully, a lot of care has been done in trying to isolate these devices and see how well they share the current and all that. So, you cannot do anything in isolation. So, the over the wall does not work. You need to make sure that all of them are done concurrently. Somebody sits and makes all these drawings and all that. So, the way we mount these stud mounted diodes, or I do not know, at the moment all I have to do is say is that you need to take tremendous amount of care to make sure that is there. I think this is over, and then something loosely related which I was showing there is, this is the, yes, you have guessed it, the earthing point. So, they have put some loose I mean what do you call, stones, we call it here as a jelly, I do not know, this is called electrical jelly, it has nothing to do with the jelly, you know. So, these stones have a particular what do you call, aggregate is all kept here, and then you see here there is a strap here, there is one more strap here. So, in a very what do you call, complicated way, it is all, you know, water is fed into this, and that small meter which I have shown you earlier is used for monitoring if there is a any leakage in the earth path. You have seen that. Obviously, even at the tremendous voltage and all that, no, a reasonable thing is, this is about the reasonable thing. Actually, it is on, and around 0.1 to 0.2 milliamperes is probably what is okay, tolerable up to 1 milliampere. The moment it exceeds any of this, then something is wrong, and then they need to switch it off. So, what I will do is, I will now close it because we do not need to see this anymore. Now, I will show you something else here. See, this was part of a biomedical equipment. This is where, so if you can see my this what do you call, please switch on this camera, sir. These are the Peltier modules which need to be used for whenever you need to do both heating and cooling at the same time. They are generally supplied in a protected condition like this. So, if it is in my hand, I do not know if it is already spoiled. Anyway, we have all this small devices. Now, you see here we have small cups in which some what do you call, some reagent or something is sitting inside, and eventually these have some liquid or I will say some medium in which growth takes place, and then some chemicals are added and so on, and what is called anti-proliferative action of some naturally occurring herbal medicine, so that can be used in cancer cure, that is made in it. My interest is not talk about herbal and other effective and all that. What we need is, you see here there is a small motor here that is connected to the carousel here. So, next picture shows you a fully assembled unit here, which can you see here, whole thing is enclosed in a dust protective environment, and if required we can even probably make sure that any external oxidation does not take place. We can probably include any wanted what do you call, air or particular type of air, it could be dry or it could be moist and so on. The issue here being, each of these small cups has a mesh at the bottom, and there are some specially hybrid seeds that have been ingrown, and they have certain properties in which their growth rate is affected. Now, the thing is, we need to closely control the temperature of this device. In such a case, using a peltier makes effect. So, we use the peltier, we can lower the temperature. After collecting all the things, they can be brought in a cold chain. After loading it here, we can see the action, whether we can maintain it at ambient or we can maintain it at our body temperature, which is typically 37 degrees, and we can raise it, because body has a natural mechanism of raising temperature locally, and how well these things work with other things. In such a case, we have no other option but to use a peltier thing, but you cannot talk of using this peltier in that huge monstrous what you call 5 megawatt panel system we are talking about. 5 milliwatt, yes, 5 megawatt, no, it is a matter of scale. I will close this.